So here's a question from vectors and I'll have to say 3D geometry. To start with, recall that the volume of a tetrahedron would be 1 upon 3 times the area of the base into height h, and the volume of the parallelepiped would be 6 times the volume of tetrahedron formed by the vectors of which the parallelepiped is constructed from. So to start with, here we have a plane P. Let's say this is the plane P, and we have a triangle which is perpendicular, which is parallel. The plane of the triangle is parallel to the plane P. So the point W is in the plane somewhere. Let's say here, to visualize, this is W. It's in the plane, but to visualize, I am drawing it below UV, though the triangle UVW is parallel to plane P. And we are given that this distance is 7/2. We are given that UVW are in the set S, which means the distance of origin from UVW is 1. Let's say this is origin, this is 1 each. Then we have so the distance of origin from plane P would be root 3 times 0 plus 2 times 0, or rather, the as we know, the distance of plane P from origin would be d upon under root a square plus b square plus c square, where the plane is ax plus by plus ez equals to d. So this becomes 16 upon under root root 3 square, which is 3, plus 2 square is 4, plus 3 square is 9. Sorry, 2 square is 4 plus 3 square is 9, which is 16 by root 16, which is 4. This is 4. So distance of origin from plane P, this is 4. That gives us this tetrahedron OUVW formed by these points. The height of this tetrahedron is 4 minus n/2, which is half. So now we need is the area of triangle UVW. Now we are given that modulus of u vector minus v vector equals to modulus of v vector minus w vector is equals to modulus of u vector minus w vector. That gives us UVW as an equilateral triangle. This is UVW, and the distance of O from this is half, and this length is 1. So if the side length UVW is A, then this length, so we have this A, this angle is 120 degree, so this is 90 degree, this is 30 degree. So we have this length is say R, then we have sine of 60 degree is equals to A upon 2R, which is root 3 by 2. That gives us R is A upon root 3. So the projection of O on triangle UVW, let's say that is O1. So we have O, O1 and the point V. This is length 1. This is the length R, which is A by root 3. And O1 is half the height of O from triangle UVW. So by Pythagoras theorem, we'll have a square by 3 plus 1 by 4 is 1, which gives us a square by 3 equals to 3 by 4, which gives us a is 3 by 2. So that means the area of tetrahedron OVWU is root 3 1 by 3 times area of the base, which is root 3 by 4 times a square, which is 9 by 4, into the height, which is half. So that becomes 3 root 3 by 32. The area of the parallelepiped formed by u vector, v vector and w vector would be 6 times this. So that becomes 6 times 3 root 3 by 32. So that is v. We want to, the answer is 80 by root 3 times v. That becomes 80 by root 3 times 6 into 32. Root 3 gets cancelled. We have this becomes 3, this becomes 16, this becomes 5, which is 5 into 9 is 45. So the answer is 45.